Right, I want to try and keep this as short and snappy as possible. So, just want you to have a quick little look at what's on the screen at the minute. And as you can see, instructional forms. There's 3 different types of question that come up. We have your hyperbolic paraboloid, which is this one here at the top. I like to call that the perimeter method, where you have a 4-sided figure in one of your views, and you have to translate that 4-sided figure to your other view, and you're given a limit for your perimeter of your object, and that limit on the perimeter of your object then is transferred to the secondary view, and sometimes you're asked for a third view for that. We have the hyperbolic paraboloid under translation, where this is a good example here, where you have your parabola ABC and it's traveling along the path, or translating along the path DBE. So it's traveling along that path, sweeping along there, and then your plan view limits the shape of what you're going to end up with, which then solves that top curve there. There's another variation of it here, where you have your parabola, your ABC parabola, and that is going to travel, point B is going to travel along the curve here, DEF. So it's like it's on a zip wire, or some sort of track, where DEF is the track that it's going to travel, and as it gets lower and lower and lower, the parabola gets shorter and smaller because it's being cut off by the ground, and then that will solve your plan view here. Okay, the one we're doing today is this one here, the hyperboloid revolution, where we have it's almost like your nuclear power plant in The Simpsons, okay, or your water tower that you might see on the roads on the way up to M50 or the M4, M3. You have your, in this instance it's a TP tower or whatever, but we have the hyperboloid revolution, where we have a hyperbola on the left and right, and it's been revolved around the central axis. Okay, so we're going to get rid of these now, and we're going to introduce now the actual question. So if I find that first, the actual question is here. Okay, and one thing to note on this is the scale, really important. Okay, I'm just going to read the question out first, and then I'm going to show you that SOLIDWORKS model that you might have got a wee preview of there a second ago. So the graphic on the right shows a building in the form of a hyperboloid revolution. Figure C2 below shows the plan and elevation of a portion of a building with a new entrance in the form of a parabola. So that bit of information is going to be key. And then the true length of all straight line elements is 40 meters. Again, very important, and I'm going to make sure to highlight that we have 4 meters. Apologies with the crooked line, but anyway, you get my drift. And then draw the plan and elevation of the building, draw the projections of the new entrance. So we're going to try and complete the view, complete the question now in a second. And what I want to just go to now is, I want to give you a little idea of what that means by the straight line elements. So if we look here at our hyperboloid of revolution, okay, we've cut it off. Alright, and the straight line element is this line here that goes from the very top of the hyperboloid revolution down to the very bottom. That's a straight line, okay, and that's an element. An element is a line that we can draw on any view. So if we look in here from the front, you can see that that's a straight line going from the very top here to the very bottom. Okay, it's a dead straight line, and turn off the perspective, that might actually just look a little bit better. That's our straight line element. So in this question, the distance from there to there is going to be 40 meters. Okay, and if we were just to quickly have a little 3D view of this here, you can see that where we're cutting that off is at the very point of the throat circle, the narrowest point of our hyperboloid revolution. Okay, so if I was to highlight that there, you can see this is the throat circle here. This is our vertical cut. It's a horizontal line in plan, but it's actually a vertical cut, as you can see it here, and that creates our straight line element. So that's going to give us a little bit of a clue as to what we have to do. Alright, so we're going to get stuck into it now, and the scale of the overall height, or the measurements that are given me are 12 meters 4 meters and 9 meters. Now, if we take that scale of 1 is to 200, first thing we're going to do is take our meters. So we've 12, 4 and 9, so that's 25 meters. We multiply that by 1,000. Why 1,000? Because you have 1,000 millimeters in a meter. And then you take that answer, which is 25,000 millimeters, and divide it by 200. And that's going to be your overall dimension of the height of your object. Okay, so 125. Okay, as you can see, I have plenty of room there for that. So I want to make sure that I have 125 millimeters in my front elevation, and I want to make sure that I have 130 in my plan. Half that 65, so that's there. Actually, so for the throat circle, we are measuring up 12 meters and 4 meters, which is 16 meters. So therefore half that is 80. So 80 millimeters. Take my compass and set that up to my measurement of 65 millimeter radius. Just darken that a little bit. Let's see how we get on. Okay. And again, to make sure to measure 6. This is my throat circle here. Okay, so what we're going to do is, we know that our full length element is going to be 40 meters. So that means from the midpoint to the base is going to be 20 meters. So if I measure that out, I can have my measurement again to scale is going to be 10 or 100 millimeters. So if I take that scale, so half of that. So this is a 20 meter line, scale down to 200 is actually 100 millimeters. And if I mark that on the center there and swing it down here, that's my base point for what we call our asymptote. Okay, so what we're doing is, as I showed you the 3D drawing here, if I go back to it, you can see here that straight line element from the very center of the throat circle to the base. We're going to have that at 20 meters. Okay, and this cut here creates those straight line elements, which we're calling the asymptote. Alright, so with my asymptote, that's my straight line element going on up there. We can take that same measurement, again just double checking to make sure my compass hasn't moved, mark it over this side. Again, that's my asymptote. What I'm going to do is I'm going to bring that point down to my base circle here, and that's our horizontal cut, or vertical cut. Horizontal line is the vertical cut coming down, giving us our measurement for the throat circle. So there's the measurement for my throat circle. I can now bring that up to my front elevation view. There's the measurement there. Okay, let me see if the light here on top. Yeah, definitely. Okay. Okay, so we now have our throat circle, our base circle, which is there. We have our asymptote, or at least the bottom half of the asymptote. We have our cut here, which is creating the asymptotes, or our straight line elements, and then we're going to create the hyperbola on either side. And the way I like to do this is I simply take my heights and I'm going to split them up. I have 80 there, so I'm going to split it into 420s. And we'll call this horizontal, or height number 1. Okay. Now, with that, I'm going to create a cut. So I'm cutting my hyperboloid revolution. This is where the point is. What you do in one view, you must do in the other. This is the point on the asymptote in my front elevation. So I bring that down to my asymptote in my plan. And now with that solid shape, if I was to cut that across horizontally, it would create a circle. So what I'm going to do is going to take that radius of cut 1 and bring it to what we call our extreme generator here. And from that extreme generator, I'll just draw that in. So this comes down, around, and then I'm going to bring this point back up to the exact same height, and that'll give me a location on our hyperbola. We do the same thing again for horizontal cut number 2. And again, don't forget to do it both sides, which I'll copy it over this side. Okay, so I'll copy it over to the top, and I'll copy it over to the other side. So we take our horizontal cut number 2. What location do we know that we can use in both views? We know the asymptote. Okay, so we know where it hits the asymptote. We know our asymptote in plan, so we can bring that down to our asymptote in plan. We can then take that radius from the central axis of the hyperboloid revolution, and we can now swing it around to our extreme generator. And from our extreme generator, we can bring that back up to the corresponding height. Again, giving us another location on our hyperbola. Again, creating cut number 3. Wherever it hits the asymptote, we bring it down to the asymptote plan. We swing it around to our extreme generator. We're rotating it around here. That's my point on my extreme generator. I must bring that back up to the corresponding height. And that is our location. So this is our hyperbola. Now, how am I going to get that hyperbola up here to the top? Well, what I'm going to do is I'm just going to bring my heights and I'm going to mirror them. So I bring that measurement up. I'm using my compass from the central axis of where the throat circle is. I'll take that mirror point and swing it up here. Take the next point, point number 2 on the hyperbola, swing it up there. Take cut number 1, swing it up there, and if you wished, you could take the extreme generator of the base circle and transfer it there, which I am not, because I'm only going to go as far as is needed. So, I'll do this first. And then fill it in our pen to stand out. That's where we stop. How do I create the other side? Well, we do the same technique. We mirror it across. So all of my points are taken across. And with our compass now, from the central axis, we take point 1, swing it, point 2, mark it off, point 3, four, 5, and even 6. Okay. And again, we will make this stand out. And that's our hyperbola on that side. Now, that's part A complete. So draw the plan and elevation of the building, which we've done. The only height that I actually need to take, because I haven't got the top circle of this, is I need to take this height here and transfer it. Again, I'm trying to make that stand out because it is visible. Same thing with my base circle. Make that a little bit heavier. Alright. Okay, so that's the part A done. Now part B is, we know that part B is our parabola. Now for our parabola, we know that it's going to come from point A up to point B and back down to point C. That's our parabola. What we can do is we can use our rectangular method for this. B is what we call our vertex. And for the side of the parabola, what I'm going to do is I'm just going to do some red pen so you can see it a little bit clearer. We're going to use the divisional lines method. So we create our own line. We split this into measurements, or into sections of 4 or more. I'm going to use centimeters or 10 millimeters. So there's 1, 2, 3, and 4. On the last point of my own line, which is the red line, I bring that to the last point of the line I need. So there's my first angle. I'm going to use sliding set squares now to slide that along to split it into 4 segments. Like so. With these 4 segments, number 1, 2, and 3, I take them to the vertex. So 3 is coming to the vertex, and 2 is coming to the vertex, and 1 is coming to the vertex. Okay, we don't know the measurement of this line. It's 25. 25 divided by 4 is actually quite difficult. I'm just going to zoom in here a little bit more, give you a better idea. Okay, so 25 is actually difficult to divide by 4, so what we're going to have to do is use the divisional lines method again. Now, at the top part of this we're finished, so what I'm going to do is I'm going to use a green pencil here. Okay, so we draw our own line. On that line we split it up into the same number of parts. It must be the same number of parts, so it must be 4. So there's 1, 2, 3, and 4. And remember, I'm only splitting up half of it. So I take my section 4 and bring it to the end of that one, sliding set squares across, and that will divide our half of our parabola into 4 equal segments. I can then take my pencil now, and this is segment 1, 2 and 3. So if I bring 3 down, wherever it cuts the other line, 3 is our location. This is our point 2, and this is our point 1. So again, to mark that in pen, we have A, we have 1, we have 2, we have 3, and we have B. So that probably is going to travel from here to there, to 1, to 2, to 3, and to the vertex. And how do we get it on the other side, or how does the ball travel back towards the ground? Well, it travels the exact same path. So if we take point 3, mirror it across, point 1, mirror it across. We take distances, always measure distances with the equipment that you have. So we have a compass, you can swing that around. Point 2 on our parabola is here. Let me just fix that again. And point 3 on our parabola is here. Again, the ball has reached its plateau, or the highest point in the air, and it's now going to fall down, hitting these points and coming down to C. So that's our parabola. Unfortunately, the focus is a little bit off there. So hopefully that balances out now again. Come on, find yourself now. Okay, so that's our parabola. Now we need to use our parabola in order to create our cut. So what are we going to do? Well, we're going to do the exact same thing that we have done before. We're going to take our heights and widths and we're going to transfer them down here. So if I was to take my width here, okay, and let's just take, say, the width of 1, okay, and we bring it down. The width of 1, the width of 2, and the width of 3. And the very, very highest point, okay, which is our vertex B. What we're going to try and do is we're going to take those heights and we're going to bring them to the extreme generator down here and then rotate them to hit those corresponding lines. So what we'll do is, one has to be in this position. So again, I'm just going to do this in red pen, so we know it has to be in that position. So we'll bring it down straight. We'll take that position, we'll use a technique that we used before or earlier on, and we'll take that out to the extreme generator here. Okay. And if I bring that down to the extreme generator, which is a horizontal cut essentially, bring it down to extreme generator here. Okay, so I'm taking this point 1, out to the extreme generator. Where is that in our plan view? Well, it's on this line down here. And if I swing that around now to hit my red line, we'll have a known location. So we swing that around and there's our location there. Okay, there's 2 points that I actually haven't brought down yet, which are A and B. So if we bring them down to where they hit the base circle, here and here, there's 2 other points. So we have A and C. And we have another point here. We're just going to repeat that process then for point 2. So we bring point 2, which is here, out to the extreme generator. Bring it down to where it is in its plan view. So what you do in one view, you must do in the other. And we will swing that around then to its known location. So swing it around. Where do we stop? Well, where is it located in the front elevation? It's located here, so we bring it down, and wherever they cut gives us our location. I just want to highlight that in red pen. It comes down there like that. Okay, we're going to repeat that process one last time. Again, here is the location of that entrance. Bring it straight down using our red pen. Let's bring it out to the extreme generator. And here, where is that location? In plan view, it's down here. What you do in one view, you must do in the other. And so, from the central axis, we rotate that round to hit our corresponding red line. And we now have point 3. So, 1, 2, 3, A and C. All we're looking for is B, and we do the exact same thing. Bring that point out to the extreme generator in elevation. Bring it down to our extreme generator in plan. Swing it around from the central axis. Wherever it hits that center point is our finished location. So we have a curve that looks like that. How do we get it on this side? Well, we simply mirror it across. So, come in here on this, just so you can see how it's done. Make sure to take point 3 across, point 2 across, point 1 across. Again, it's a mirroring technique, so we just take our compass, whatever measurement it is on one side of the line, it must be on the other. There's the measurement for 1. Swing over there and join them up. And that's our solution finished. Okay.